Hi everyone! This week we are working on process capability and capability index, and I want to differentiate in this video between control limits and specification limits because they may look the same and they sound similar, but they are actually not the same thing. So control limits are what your process is capable of. That is the range over which your variable that you're looking at or your attribute that you're looking at naturally fluctuates. Specification limits are limits that you set on that particular variable or attribute. So say you have a process temperature that you're tracking. It naturally fluctuates up and down a couple of degrees, but you may not want that fluctuation in your specifications. So what I like to do to think about specification limits versus control limits is think about putting a car into a parking space. Let's take a look at how that works. Here we have our little car. So the control limits are the width of your car. The specification limits, the ones that you set, that is the size of your parking space. And so if your car is smaller than your parking space, if your control limits are smaller than your specification limits, that's great. You can park your car in the space, no problem. If your control limits and specification limits are the same thing, that means your little car here is just as wide as your parking space, and you're going to have to be very careful about how you park it so you're exactly in that space. You're not sticking out on one side or the other. If your car is bigger than your parking space, well, then you can't get it in the space, regardless of what you do. So let's see an illustration of that. Remember, the width of our car is the control limits. That's just how wide our process is. That's the natural fluctuation that we get that we can't do anything about unless we go about changing our process. Our specification limits are what we set. That's our parking space. So the goal here is to get the car into the parking space, completely into the parking space. We don't want to stick out because then we make somebody else mad because they can't use the space next to us. All right, here is a very well controlled process. You can see that this car fits into the space and you can wiggle it one way versus the other way and it's still okay. You know, we can do a halfway decent parking job. Let's say we park like this, but we're still in the space, and that means the person that's trying to use this space next to us is okay. They can park in there. Now let's say our car is a little bit bigger. Our process has a bit more variation. Well, if we do a really careful parking job like that, then we can fit entirely in this space. But let's say we're in a hurry and we're a little bit off and we come scooching in like this. We say, okay, well, that's our parking job for today. Well, that's not good because we're hanging over the edge of our space. We could fit in to our space. We could make our specification limits, but since we didn't center our car or our process properly between these two lines here, our parking lines or our specification lines, we're sticking over on one side, and that's not good. So we have to go back and fix our parking job like that, so we are in our space properly. We're properly centered. If we're not dead center here, we're going to hang out of this parking space. Okay, let's say we have an even bigger car. So here we go, this really, really big car. That means our process has got a lot of variation. And you notice that we're sticking out on both sides of our parking space or our specification limits. There is no way we can park this car completely in the space. It is not possible. Our car is too wide. It's going to hang out. If we fix one side so we're in the space, the other side is way over. We say, okay, well, let's try centering it. Then we're over on both sides. And the same thing if we try to fix the opposite side. We're hanging out on the first side now. So this big car, it's impossible to meet our specification limits because we're just too big for the space. So as you're going through your processes and thinking about, all right, what is my process actually able to do in terms of variation versus what I want it to do, my specification, what kind of car do I have? Do I have a little car that I can allow a little bit of variation and I'm still in the space? Do I have a car that's just wide enough to fit it in the space if I park perfectly? Or do I have a car that's just too big? I need to go find a bigger parking space, or I need to go buy a smaller car. Ideally, what you want is this blue car up here where you can have a little bit of wiggle room. Let's say you have a little bit of process fluctuation and your process center shifts a little bit. Well, that's okay, because even if you have a shift in your process center, you're still within your spec limits. You're still in your parking space. This process, if you deviate at all from exactly between those limits, you're going to go out of spec. And since nobody's perfect, you're probably going to be out of spec a decent amount of time. This is the worst case scenario, our little red car down here, because we can't get him in the parking space regardless of what we do. We're going to have to go buy a smaller car, or we're going to have to go find a bigger parking space. So there you have it. That's my illustration of spec limits versus control limits. It's easier to think about it if you think about your process as a car, your specifications is your parking space. This may be a good analysis for your course projects as you are trying to bring down any kind of variation, or you're trying to look at what your adjustments did to your particular process. You have specification limits. Those are your goals. So think about how your little car, your process, is fitting into your goals or your specification limits. Did you do a good parking job? Do you need a smaller car? Or is everything, looking really good like this blue car up here? Again, this is our ideal situation, and this is what we want to have in terms of our processes.